Hi students, welcome to yet another teaching module in economics. As you know, we have begun with the topic elasticity of demand. In the previous lesson, we learned about one method of calculating or finding the elasticity of demand, which is price elasticity of demand or percentage method of finding elasticity of demand. Today, we will delve into some other methods of finding elasticity of demand. So here we go. In this lesson, we will learn about two other methods of finding the type of elasticity. The first one, the expenditure method of finding the type of elasticity, and the second, the geometric method of finding elasticity. Before we jump into learning about the expenditure method, I would like to say on the outset, when we go to purchase something, some good, maybe vegetables, as you see in the picture, what we do is we spend our money. And how do we do that? We multiply the price with the quantity of units demanded of that good. So price multiplied by quantity demanded will give us the total expenditure. That is what we are to pay the vendor. For example, in the picture, 2 cabbages are bought at rupees 40 each. So the vendor tells the customer, that would be rupees 80 please. How do they arrive at rupees 80? Multiply the price, that is rupees 40, with the quantity demanded, that is 2 units. So that is how you arrive at total expenditure. Having said that price into quantity demanded gives us total expenditure, let us now venture out into studying the relationship between elasticity of demand and total expenditure. This method is called the expenditure method of finding elasticity of demand. It was Alfred Marshall, the economist, who found that there is a relationship between elasticity of demand and total expenditure. So let us study this expenditure method and this relationship with the help of this table. Here you have the good A, good B, and good C. Say for example, when the price of good A is rupees 1, 8 units of good A are demanded. So the total expenditure on good A is rupees 8. 1 multiplied by 8 gives us 8. In the second instance or second situation, the price rises is seen to rise to rupees 2. In that circumstance, the quantity demanded is 4 units. When you multiply 2 by 4, you get the total expenditure. You can clearly see in the case of good A, when price falls to rupees 1 or price rises to rupees 2, basically there is no change in total expenditure. When there is no change in total expenditure, it is seen that the type of elasticity is seen to be unit or unitary elastic. Let me repeat again. If the price falls or rises and there is no change in the total expenditure, then the type of elasticity is unit elastic demand. Let's look at the next good, B. When the price of good B is rupees 1, the quantity demanded is 10 units. The total expenditure on good B at that price is rupees 10. See, for example, the price of good B rises to rupees 2. In that instance, the quantity demanded reduces to 4 units. 2 into 4 is 8. The total expenditure at price 2 on good B is rupees 8. So we see something happening here. When price falls to rupees 1, total expenditure rises to rupees 10. And when the price rises to rupees 2, the total expenditure is seen to fall to rupees 8. So you can see there is an inverse relationship between price and total expenditure. And when there is an inverse relation between price and total expenditure due to a rise or fall in price, then we say the demand is relatively elastic. I'll repeat, if there is a fall in price and as a result there is a rise in total expenditure, and if there is a rise in price, as a result there is a fall in total expenditure, then the type of elasticity of demand is relatively elastic. Let's see the case of good C. When the price of good C is rupees 1. For example, the quantity demanded is 5 units. So the total expenditure on goods C at that price is rupees 5. When, say, price rises to rupees 2, the quantity demanded at that price is 4 units. 2 into 4 gives us 8. So we see when price falls from 2 to 1, the total expenditure falls from 8 to 5. And when price rises from 1 to rupees 2, the total expenditure falls from rupees 5 to rupees 8. So you see there is a direct relationship between price and total expenditure. Both of them fall and both of them increase. When the price rises, total expenditure rises, and when the price falls, total expenditure falls. The elasticity of demand in this case is said to be relatively inelastic. So what is the relationship between price, elasticity of demand, and total expenditure? As I told you earlier, Professor Alfred Marshall, the economist, worked out a relationship between elasticity of demand and total expenditure. He estimates the degree of price elasticity of demand depending on the changes of total expenditure due to the change in own price of the commodity. Having examined the relationship between price elasticity of demand and total expenditure with the help of an example that we studied in a table, let us now try to define the types of elasticity in terms of total expenditure. So here we have the first one, unit elastic demand. If a rise or fall in own price of the commodity causes no changes in total expenditure on the commodity, then elasticity of demand is unit elastic. The second type, relatively elastic demand. If a fall in own price of a commodity causes a rise in total expenditure and a rise in price causes a fall in total expenditure of the commodity, then elasticity of demand is relatively elastic. The third case, relatively inelastic demand. If a fall in own price of the commodity causes a fall in total expenditure and a rise in price causes a rise in total expenditure on the commodity, then elasticity of demand is said to be relatively inelastic. I've taken another example for you to help you to understand better. So here we've taken different figures. You have good A, good B, and good C. Here you have price rupees 3. At price rupees 3, quantity demanded is 4. So the total expenditure is 12. When the price falls to rupees 2, the quantity demanded is 6 units. 2 into 6 gives us 12. We can clearly see in this case there is no change in total expenditure. So what is the type of elasticity? When there is no change in total expenditure, even if the price rises or falls, the type of elasticity is unit elastic demand. Let's examine the second good. When the price of good B is rupees 3 or increases from 2 to rupees 3, the quantity demanded is 4 units. 3 into 4 gives us 12. Say for example the price falls from 3 to 2 units. The quantity demanded is 7 units at that price, rupees 2. So 2 into 7 is 14. So we clearly see that when price falls from 3 to 2, the total expenditure rises from 12 to 14. And when price rises from 2 to 3, total expenditure falls from 14 to 12. We can see with the help of arrows, it is shown clearly. When you see that there is an inverse relationship between price and total expenditure, you know that the type of elasticity is relatively elastic. In the third case, with good C, if the price is rupees 3, 4 units are demanded. 3 into 4 is 12. When the price falls from 3 to rupees 2, the quantity demanded is 5. And 2 into 5 is 10. So we see when the price falls from 3 to 2, the total expenditure falls from 12 to 10. And say for example the price rises from 2 to 3, total expenditure rises from 10 to 12. We can see this direct relationship with the help of the arrows, that there is a direct relationship between price and total expenditure, and when that comes about, then we know the type of elasticity is relatively inelastic. Let us now move on to the second method, that is geometric method. This method measures price elasticity of demand at different points on the demand curve. It is also called point method of measuring elasticity of demand. We use the geometric method with reference to a linear demand curve, which is a straight line shown as follows. If you observe the diagram, we see the demand curve is MN, which is a linear demand curve touching both the X and Y axis. We take the midpoint of the demand curve to be P. So therefore, MP is the upper segment of the demand curve and PN is the lower segment of the demand curve. Why are we stating this? It is because in the geometric method, elasticity of demand is calculated by dividing the lower segment by the upper segment. That is the length of the lower segment divided by the length of the upper segment from a point. The point being the midpoint. So if we express in terms of the formula, then it will be Pn, which is the lower segment, divided by Pm, which is the upper segment. Therefore, in the geometric method, we are trying to study what is the elasticity of demand at the various points on a demand curve. So you see at point P, the elasticity of demand is Pn upon Pm. Pn being the lower segment and Pm being the upper segment. Since both are equal, because we are talking about the midpoint, which means both the lower segment and upper segment are equal at the point P. So when we divide, we will get 1. ED will be equal to 1. So the type of elasticity at point P is unit elastic demand. At point A, elasticity of demand at point A is equal to lower segment AN divided by upper segment AM. As we can see, AN is greater than AM. So we will definitely get a number greater than 1. And we all know that when elasticity of demand is greater than 1, it is relatively elastic demand. Let us examine at point B. At point B, the formula for elasticity of demand is Bn, that is lower segment, divided by Bm, that is the upper segment. We can see that the lower segment is lesser than the upper segment. So we will get a fraction. And when we get a fraction, the elasticity of demand will be less than 1. We know when it is less than 1, it is relatively inelastic demand. So just say for example, Bn is 2. The length of Bn is 2. And the length of Bm is 6. So 2 upon 6 is 1 upon 3. So you get 0.33 and so on. So which is definitely less than 1. And so therefore the type of elasticity is relatively inelastic demand. At point M, the lower segment is the entire demand curve, which is Mn. Is there an upper segment to this from this point? No. So upper segment is equal to 0. So Mn upon 0, we know any number divided by 0 is equal to infinity. And when elasticity of demand is equal to infinity, what is the type of elasticity of demand? It is perfectly elastic demand. Now let us go to point N. At point N, which is on the x-axis, There is no lower segment. So the lower segment is 0. The upper segment is therefore the entire demand curve NM. So 0 divided by NM, because lower segment is 0. Lower segment divided by upper segment is 0 upon MN is equal to 0. And we know that when elasticity of demand is equal to 0, the type is perfectly inelastic demand. Here is an example to revise what we have just learned. If the length of the lower segment is 4 and the upper segment is also equal to 4, then elasticity of demand is lower segment from a point divided by upper segment from a point, which is equal to 4 upon 4 equals to 1. When ED is equal to 1, the elasticity of demand is unit elastic. You can take any other examples and change the length of the lower segment and upper segment and practice and see what types of elasticity you can get. So students, today we have learned the following methods of finding elasticity of demand. That is the expenditure method and the geometric method. Previously we learned the percentage method of calculating elasticity of demand. With this learning module, we have come to the end of the chapter Elasticity of Demand. In the previous lesson, we learned about the percentage method. Today, we learned about the expenditure method and the geometric method of finding elasticity of demand. I encourage you students to view the videos again, all the videos from demand analysis, and revise whatever you've learned. Complete your notes, solve your problems, complete your diagrams, revise the entire chapter, and you will feel more intelligent and you will be brighter. So happy learning, dear students. This is teacher Shirley signing off today.